Let's integrate secant to the 5th power theta. We're going to have to use integration by parts for this, so I'm going to break up the secant to the 5th power into a product of secants with smaller powers. So I'm going to have secant to some power theta times secant to another power of theta d theta. And if I had secant squared theta, that would be easy to integrate, because the integral of secant squared theta is just tangent theta. So let me make this one secant squared. So to get secant to the 5th power, this is going to have to be secant cubed theta. So now I can do the integration by parts. I will have a u and a dv, so this can be my u, this can be my dv. Now I have to get the du and the v. So to get the v, I'll have to integrate the dv. So when you integrate secant squared theta, you get tangent theta. And to get the du, I'll have to differentiate this. And let's do it carefully. So we're differentiating secant cubed theta. So I'm going to write this as secant theta cubed. And you know you're going to do the power rule. You're going to take the 3 and bring it to the front, and then subtract 1. So we're going to have 3 secant now to the 2nd power theta. But then we have to use the chain rule and multiply by the derivative of the inside. So the derivative of secant theta is going to be secant theta tangent theta. So I'm going to just put this down right here, and I see secant squared theta times secant theta is going to be secant cubed theta. So I'm going to erase this and then write it down over here. So this was 3 secant cubed theta tangent theta d theta. So now I have the integral of u dv is going to be equal to uv, so this times this, so secant cubed theta tangent theta, minus the integral of v du. And this is kind of sloppy. Let me see if I can write it a little better. Alright, anyway, so we have the v du. So perhaps I will put down, for the v, we have the tangent theta. For the du, I have a secant cubed theta and another tangent theta, so it's going to become tangent squared theta. And then for this 3, I will put it down in the front of the integral, and then we still have the d theta right here. Alright, now I'm going to use an identity. So this is still secant cubed theta tangent theta. Then minus 3 integral, I know that tangent squared theta, let me put this down in red, tangent squared theta is the same as secant squared theta minus 1. So I'm going to keep this part right here the same. So I have the secant cubed theta right here. And then the tangent squared theta is, I'll put it in red, secant squared theta minus 1. And now I'm going to do some distribution. So this is still this part right here. And then I have minus 3. So my first integral, I'm going to do this, is going to be secant to the 5th power theta. And then I'll close this integral and do the next integral, which is going to be this times this times this. So we have minus 3 times minus 1 is going to be plus 3 times this times this. So you have the secant cubed theta d theta. Alright, now I notice a repeat. I have this right here. I started off with integral, remember this is integral of secant to the 5th power theta d theta equals all this. So this showed up again. So that suggests that I bring down the original. So let me move this over slightly and put down right here that the integral of secant to the 5th power theta d theta equals all this. So now what I'd like to do is add this on both sides so that I can cancel it out. Oh, and I have to add 3 of them here as well. So you will see that on the left, now I have 4 integral of secant to the 5th power theta d theta equals, we still have this right here, secant cubed theta tangent theta. This is gone, and then we're just left with 3 integral of secant cubed theta d theta. So I still have to work this part out. So I'm going to solve this integral. I'm going to save this, and then I'm going to make a new slide, and we're going to focus on the integral of secant cubed theta d theta. Once again, I'm going to break this apart because I'd like to have a secant squared theta d theta that I can integrate. So I'm going to put this down like this. And now I'm going to do another integration by parts because I know that this is going to be easy to integrate. So I'll make that be my v, and I'll make this be my du. So, this is my dv right here, and then this is the u right here. So integral of dv is v, and then integral of secant squared theta d theta is tangent theta. And then over here, the du is going to be the derivative of secant theta, which is going to be secant theta tangent theta d theta. So now this integral is going to be, again, uv, so uv. So secant theta tangent theta minus the integral of v du. So we're going to have secant theta, and then I have tangent theta times tangent theta is going to be tangent squared theta, and then I still have the d theta right here. And once again, I'm going to use the identity that tangent squared theta, I'm just going to save some space and rewrite it right here, is the same as secant squared theta minus 1. And now I'm going to expand this again, so I have secant theta tangent theta minus, so the first one is going to be minus the integral of this, so the integral of secant cubed theta, and I'm going to close this integral, and then I have this times this for the second integral, but don't forget this negative on the front, so it's going to become plus integral of secant theta d theta. Once again, I see a repeat of the original, so I'm going to bring that down. I know that the integral of secant cubed theta d theta is equal to all this. And now I'm going to add this integral on both sides. Add it here, and I will add it here. Let me write this down a little better. Secant cubed theta d theta. So on the left-hand side, we have 2 integral of secant cubed theta d theta equals, this part is still the same, secant theta tangent theta. This cancels out. What's the integral of secant theta? Well, that's an integral you're probably going to want to memorize, and I've done a video on how to integrate that, and I'm just going to put down the standard result, which is natural log absolute value of secant theta plus tangent theta. Now I'm just going to multiply both sides by 1/2, so I have the integral of secant cubed theta d theta equals 1/2 secant theta tangent theta plus 1/2 natural log absolute value of secant theta plus tangent theta. So now we figured out the integral of secant cubed theta, and I did not put down plus c because we are not through with the big integral. So I'm going to take this and go back to the first slide and plug it back in. So let me go back there. So we figured out this part right here. So I'm going to copy this down. 4 integral of secant to the 5th power theta d theta equals secant cubed theta tangent theta plus 3, and then the result of this was 1/2 secant theta tangent theta plus 1/2 natural log absolute value of secant theta plus tangent theta. And now we are almost done. I just need to multiply both sides by 1/4. So in the end, we see that the integral of secant to the 5th power theta, d theta, that was the original problem we were trying to solve, is going to be equal to 1/4 secant cubed theta plus tangent theta. Well, there's no plus here. This is just secant cubed theta times tangent theta. Alright, now do this carefully. You're going to have 3 times 1/2, but then we're also multiplying by 1/4, so you're going to get 3/8 secant theta tangent theta. And again, 3 times 1/2, then we still have multiplying by 1/4. We're going to get plus 1/4. Well, we're going to get plus 3/8 natural log absolute value of secant theta plus tangent theta. And now I will put down a plus c because we are at the end of the big integral. And this is our result of the integration.